So now you're probably asking me, what does all this have to do with derivatives? Why did we spend an entire chapter on doing derivatives? Well, I do want to show you why. This is a program that just kind of lets you graph any kind of function and then observe tangent lines, normal lines. I don't even know what these other ones are. But if you kind of follow this pink line as I trace it along this function. So this is a sine function, by the way. I just want you to kind of observe this tangent line. So right now it's getting pretty steep, a negative steep rate of change. Alright, now it's going to start to get less steep, less of an incline. And as I reach this relative minimum, you'll notice that it's going to flatline. Alright, and then as I trace this up some more, I'm reaching an absolute or a relative maximum, a peak of a hill. Another flat line. And then you can kind of just see as this rate of change right here, once again as we do a valley, that rate of change, 0. It's 0. Alright, so how this has to do with derivatives is what we have are what we call critical numbers, and the critical numbers are values of x for which the derivative f prime of x is equal to 0 or is undefined. So in that example where you saw that pink line, flat line, what you notice, those slopes, the slope of those tangent lines, so in other words the derivatives, at those instances they were equal at 0. So trying to bring this all together now, we're going to look at examples. And you'll notice I have a function here. And its graph. So in order to find the critical numbers, what I have to do is I have to derive it first, because I'm interested in for what values of x is the slope equal to 0. So when is the derivative equal to 0 or undefined? But here I go. I'm not going to derive anything yet because you could see that I have this x squared times this factor of x minus 3. And you'd have to use the product rule on that because you have something, a function times a function here. But instead of doing that, I'm not going to derive anything. I'm just going to distribute that x squared. So what I get is x cubed minus 3x squared. So no deriving yet, just a rewrite. Now I'm going to go ahead and derive this thing. So I am going to find out what is the derivative of f of x by deriving what it is equal to. And x squared minus 3. Okay, what you will notice is I can now just use the difference rule. I can take this term by term. And as I write this, I am going to write our different notation, f prime for a derivative of our f. I'm going to take it, the derivative, oops, sorry, that should have been an x cubed. X cubed minus the derivative of 3x squared. Okay, so this is all equal to, I can just use the power rule because these variables are the same. So I'm just going to pull down that 3 and then reduce our exponent by 1. Minus, I am going to go ahead and just ignore that 3. It is a scalar multiple, so I can just ignore it for now. And then what I'm going to do is take the derivative of this x squared. So the derivative of x squared would just be 2x. So now, simplifying this all out, what I'm going to get is 3x squared minus 6x. So yay, we have the derivative. But don't forget our question. We're actually trying to find the critical numbers of the function. So now that we have the derivative, you can go ahead and just say, alright, I'm interested, when is this slope of our tangent equal to 0? That's what a derivative is. So when is 3x squared minus 6x equal to 0? So right now, you can see that I have a common x term in both. I'm going to pull that out. We're going to get 3 left inside x minus 6 is greater than 0. Now I can just use the fact that if one of these factors equals 0, then this whole thing is equal to 0. So the solutions for this, the x values that will make this 0 are going to be, well, if x equals 0, then it's going to be 0 times negative 6, which is going to make this statement true. And then also, if 3x minus 6 is equal to 0, so this factor right here, I'm going to solve for that. What we get is x is equal to 2. What you're going to notice is if you look back on this function, this is our function right over here of this x squared times x minus 3. If you look at the values x equals 0 on this function and x equals 2 on this function, what we have just found were the values for which our tangent line slope, whoops, that's a dotted line and a tangent line, our tangent line was equal to 0, or our slope of our tangent line. In other words, our derivative was equal to 0. Alright, here's another one. Because remember in the definition it says we're interested in when our derivative is equal to 0 or undefined. So let's take a look at this. This is actually problem number 1 from the homework assignment, and it says find the value of the derivative at each indicated extremum. And in their picture, or in your book, you have a picture of this, and they were saying here is an extremum. Extremum is singular for extrema. So here is basically a minimum value. And what it wants you to do is find the derivative at that point, or the value of the derivative. So I'm going to go ahead and derive. I'm going to take this function. There's not a whole lot I can do other than our low to high minus high to low all over low squared. So here I go. F prime of x is going to be equal to low d high minus, and then high d low. I'm running out of room. Okay, all over low squared. So I'm going to shift this all over because I kind of ran out of room. So notice I haven't derived anything yet. I'm just using the quotient rule. And I'm going to have to go back now and derive each one of these parts. So I have, this was my low, I have this is equal to x squared plus 4. And then I am going to derive that x squared now. So it's going to be 2x minus, and then x squared now, times the derivative. And this is just going to be able to be taken piece by piece. So 2x, so the derivative of x squared was 2x, and then plus the derivative of 4, which is just going to be, it's a constant, so 0. X squared plus 4 squared. Now I'm going to simplify. If you can simplify ever, do that. So here I'm going to get So this is f prime of x. So in other words, the derivative. And once again, a derivative is the slope of the tangent. So we're supposed to find the value of the derivative at the indicated point. So if you look on here, this is the point I'm interested in. So if I ask you, find the derivative at the point 0, 0, I hope you know that all we're going to be doing is taking that derivative, plugging in that x value. So we get 8 times 0 over 0 squared plus 4 squared. And what you're going to find, I don't even care about the bottom part. All I know is the top is equal to 0. Bottom just so happens to equal 16. But this thing is equal to 0. Not a big surprise, because what we discussed is if we did draw a tangent line through this valley, this bottom part of a valley, what we would get